Hello and welcome back. Now in this video, I want to talk to you about application security with a service called AWS Secrets Manager. When developers generally build their applications that need to connect to backend databases, that application needs some form of authentication mechanism to connect to that database. Now, an age-old tradition that often tends to happen with a lot of developers, especially if they're building development environment or testing environment work, is to embed the database credential details within the application code itself. It's really bad practice, and in a real world situation, in production environments, you want to avoid at all cost. Let's take a look at AWS Secrets Manager and how it can improve your application security posture. And so let's introduce you to the AWS Secrets Manager service. This is a configuration tool that helps you to securely store, retrieve, rotate, and manage secrets such as database credentials, API keys, and any other configuration information that your application may need to retrieve at runtime. It acts as a store of configuration information or secrets. It will protect your secrets from unauthorized access as a result of enforcing IAM policies and IAM roles, and by encrypting the data that's held in Secrets Manager. It allows you to use SDKs for your applications to interface with Secrets Manager and retrieve secrets data at runtime. And it offers the ability to automatically rotate your secrets at regular intervals using Lambda functions. This is really a particularly important element and feature of AWS Secrets Manager, because what it does is it actually allows you to also enforce credential information rotation for your backend services like your RDS databases at regular intervals, in the same way as you might have a password policy for your IAM users. This means that you can automate the rotation of those credential information and keep them that extra level bit secure. It also integrates with other services such as RDS, Redshift, and DocumentDB to automatically sync credential rotation. So Secrets Manager will store the credential data for you in a secure manner, and using the Lambda functions will enable you to rotate those secrets at regular intervals, 7 days, 30 days, 60 days, whatever is your particular corporate policy. But in addition to that, if you're using any of the integrated services like RDS, Redshift, or DocumentDB, you can actually sync that credential rotation with those services as well, so that that credential data is automatically rotated within the service, rather than you having to manually play another Lambda function to automate that rotation for you. And for other services that are outside of those integrated lists, then you will need to write your own custom Lambda functions, but obviously that's something that's fairly easy to do. Let's take a look at a diagram and see a typical setup without Secrets Manager next. And so here's a quick example to illustrate how a typical application may connect to a backend database without using Secrets Manager. Now, full disclaimer here, there are obviously other ways of doing this, but in a very broad sense, the point that I'm trying to illustrate is that often developers tend to be focusing primarily on the application code and the functionality of that application, and may start forgetting about the core security element about how that application connects to backend services. So in this example, if we take a look at a piece of an application code, now this particular application code is written in PHP and essentially has the necessary credential information to connect to the backend database. This snippet of code is actually hard-coded in the application files stored on the server in plain text format. In fact, this particular developer really doesn't care about security. He's gone and actually named the password. But that's a discussion for another day. The point is that although the application will be able to connect to the backend database, no issues there, the fact that the credential data, the sensitive information, is hard-coded within the application on the actual server in plain text format lends itself to the possibility of being hacked, and potentially a malicious attacker, if he or she were to gain access to that server, could access the sensitive data that's available on that server, which is clearly written in plain text. At this point, your backend database is vulnerable to further attacks, exploitation, and potentially loss of vast amounts of data into the wrong hands. This is something we definitely want to avoid, and I would like to show you how we can use Secrets Manager, where we re-architect the application architecture to ensure that such potential risk factors are mitigated. Let's look at that next. And so let's take a look at how we can redesign the application architecture if we were to incorporate Secrets Manager in order to handle and manage all of the database credential information that the application requires to access the backend database. Let's take an example developer here, Menu. He's a security-focused developer. And let's assume that Menu goes ahead and deploys the RDS database, which hosts all of the corporate data. Now, what Menu would need to do is actually work with Secrets Manager and create a secrets information for the RDS username and password for the purposes of this example. Secrets Manager also allows you to integrate with KMS, the key management service, so that you can encrypt secrets data. Now, you can either use the AWS managed keys for it or even create your own customer managed keys if you wanted that additional level of flexibility. The next thing that Secrets Manager can do is it can be configured to actually set up a rotation policy so that the secret username and password can be rotated on Secrets Manager at regular intervals. And furthermore, that same data can be synced with the RDS database so that in effect you update the RDS database credentials and then you also update Secrets Manager's credentials with that same information. Now, a Lambda function in the backend performs all of the heavy lifting to get this job done for you, which is really awesome because it means that you don't have to get too much under the hood in order to set all of this up. Obviously, if you're using a non-integrated service, not a relational database like RDS or Redshift, then you would potentially need to build your own Lambda code in order to do the syncing element for that rotation policy for that credential data to be rotated at regular intervals. An important aspect here to note is that Lambda is obviously going to need an IAM role in order to have the necessary permissions to do all this wonderful magic in the back end. Once we have all of this in place, the next thing that Menu would need to do is actually update the application code that you saw earlier. This time utilizing the AWS SDKs for the purposes of this example for PHP. Okay. Now, AWS offers you SDKs for all of the most common popular languages, and you can use the SDKs, software development kits, to effectively allow you to integrate with backend services on the AWS platform. For the purposes of this demonstration, you can see that we've actually changed the application code so that we're no longer now storing the actual credential data in plain text. Instead, what we're going to be doing is fetching that configuration information using our variable information to retrieve the data from Secrets Manager. Okay, and this is done at runtime. By redesigning your application code in this manner, you mitigate the risk of storing those credential information in plain text, which a potential hacker might get access to. In order for the application running on your EC2 instance to be able to fetch the data from Secrets Manager, it does also need an IAM role. And you would need to configure this IAM role to give the application the ability to go and fetch that data from Secrets Manager. Once it's able to do this, accessing the RDS database is a lot more secure, and you've just improved the application security posture for your organization. Okay, so that explains all the theory and how you would go about, re-architecting your application in order to use Secrets Manager. I wanted to give you a quick demonstration on the AWS Secrets Manager console of where everything is and show you how you can go about creating a secrets information. Okay, so here we are on my AWS Management Console. I wanted to quickly take you to Secrets Manager and just do a quick demo about where all the various features and settings are for Secrets Manager. Secrets Manager allows you to host secrets information and configuration data that you can retrieve at runtime from your application code rather than having to hard code your application with those sensitive pieces of information. Now, I currently have a secret already for one of my databases, but I wanted to quickly show you how you can set this up. So all you need to do is go into Store a Secret, and then you get to set up the configuration. Now, you have a template basically where you can define secrets for Amazon RDS, DocumentDB, Redshift cluster, another type of database that you have perhaps configured, or any other type of secret information, whether it's an API key or a username and password, whatever it might be. Okay, I'm just going to click on any other type of secret there. And then you need to provide your secrets in key value pairs. So this, for instance, could be username, and it could be my user. Okay, and then you can add another row. So the password could be my password. Obviously, you would come up with something a little bit more ingenious than just my password, but hopefully you're beginning to get the idea. So these pieces of information are then going to be stored in Secrets Manager. You can also look at the plain text version, which you can just copy and paste into any other tool or service that you need to. But once you've set up what your secret values are, your key value pairs are, you can then define whether you want to use the AWS Secrets Manager's managed key. Okay, so this is the AWS's managed key for KMS, for Secrets Manager, or your own customer master keys as well. So I'm going to click next, and then you need to give your secret a name. And often what you can also do is add prefixes and delimiters to kind of separate out your secret information for different environments. So for instance, I could have an environment that says dev my application secret. Okay, and then I can also have the prod version of that secret. So prod my app secret. Okay, and then you give it a description if you wish, and that is for your production environment for that particular application. You can also replicate your secrets to other regions for the purposes of being able to use that secret information in a different region. I'm just going to go ahead and click next. And this is where you can set up a rotational schedule, right? So you can enable automatic rotation and define a schedule for your rotation. So these can be hours, days, weeks, or months. Okay, so I could do it, for instance, every 7 days. And then what would happen is at the designated time, the secret information will be changed using a particular Lambda function. So in this case, you would need to create a Lambda function, okay, which would take you into AWS Lambda, and then you would deposit a code in here to actually set up your function, and then you would click next. So I'm going to just disable automatic rotation for now and click next. So I've got my secret type is other type of secret. I'm using the AWS Secrets Manager's encryption key. This is my secret name. This is the name that I'm going to reference in my application code. And remember, if my application is running on an EC2 instance, that EC2 instance needs to have an IAM role in order to talk to Secrets Manager. Okay, so that's critical for this all to work. A rotation schedule, if I wanted one, the function that's going to be used to do the rotation, and you're even provided with some sample codes depending on what your application is built on. So for instance, if you have a Python application, then an initial helper code is here to help you retrieve your secrets. And then once you've retrieved your secrets, you need to define in your code how you use them. Okay, so that's where your code is going to go in defining exactly how you use that secret information. And once you're happy, you click store. And that is your secret status stored. So I'm just going to go back to secrets, and there you go. So that's prod my app secret over there that I've just set up. Okay, and that's a quick demonstration of Secrets Manager. We have an upcoming project video that I am going to be creating. It's going to be on the Elastic Beanstalk service, and I'm actually going to demonstrate how we use Secrets Manager in that service. But I'll see you guys then, and I hope you enjoyed this video. Remember to like and subscribe so that you can get notifications of any new videos I post on this channel. Thank you.